Good morning, everyone. I'm going to go ahead and get started. Thank you for coming today. Really appreciate it. And thank you for putting up with Mother Nature in the snowstorm. You are likely expecting to see Jim DiCarlo here. I am not Jim. I am Erik Vogan, the Executive Director of the Quest for Intelligence. Jim had a prior engagement, and so I'm stepping into his place to introduce the talks and conversations you're going to hear today. And give you some overview for what the Quest for Intelligence is, what our research is focused on, and what you're going to be hearing through the rest of the day. So, our belief is that just as humans are on a quest to understand the origins of the universe, the creation of life, we can understand the human brain in engineering terms, as a machine, just as we understand our cell phone from the level of transistors up through hardware modules to the operating system to the apps that you interface with. The brain is going to be understandable in these kinds of terms and recreatable in a machine setting. Now, you don't have to look very far to see examples of where AI is not functioning as we would otherwise intend. Whether you're interacting with Alexa or Siri or ChatGPT, they frequently don't understand the intentions that you have. They frequently give you incorrect information. Robots still aren't commonplace in the house. Where they do exist, think your Roombas, your automated lawnmowers, they don't do what you expect them to do on a routine basis. And for all of the amazing advances in artificial intelligence, the large language models in particular, they require massive amounts of power and data, and they still underperform what we see from human beings. To take a quote from Richard Feynman, "What I cannot create, I do not understand." But if we compare this to human intelligence, well, there we obviously have a full understanding, right? No, unfortunately not. We still have disorders like bipolar disease or conditions like autism. We have learning disabilities or an inability to teach to the way individuals learn. We have social situations where we see strife and conflict, and we don't entirely understand how to remedy or address these. The quest then is on a scientific understanding to address intelligence itself, to build the science that is necessary to understand human intelligence. And to do this, we need a new type of understanding, a new strategy, and a way to execute on that strategy. So the Quest is a community of people. This community goes beyond simply the faculty. It's the students, it's the postdocs, it's the research scientists, it's the software engineers and the staff who support this. And you're going to see representatives of that community here today talking about the work that they're doing. This is a photographic view of that community. In summary, we've got about 120 people. That number is loose and routinely changing, comprised of about a quarter faculty, a significant number of graduate students and postdocs and research scientists. Interestingly, the split is about 1/3 computer scientists, 2/3 natural scientists, but those numbers are probably the hardest to pin down because we see an increasing number of both faculty, students, and staff who fit both categories, and that's by design, and that is the type of community that we're continuing to build. So, the Quest itself is not simply a logical structure, but a physical structure within MIT. So many of you know the MIT campus. I've outlined it here in red. If you focus in on the portion of campus that you're on today, immediately next door, we have Building 46, the home of the Brain and Cognitive Science groups. We also have Stata across the street, housing CSAIL and much of EECS, along with additional buildings down the street. You're in the Schwarzman College of Computing, located at a nexus between these two. And the Quest is located on the 3rd floor here in this building, bringing together, convening people from all of these disciplines as well as all of the schools on campus. So, what is the Quest research strategy? How are we going to create this new understanding of intelligence? In part by bringing together the natural scientists, the neuroscientists, the cognitive scientists, the life scientists, with the computer scientists, the roboticists, the folks working on hardware and software, each focusing on the research strategies that they employ best, most productively. In the life sciences, these are experimental measurements and discoveries. On the computer science side, these are the creation of software and hardware platforms, as well as the theory about how those then function as modular components. These come together to create integrated machine executable models of domains of intelligence. And we then, from those models, have the leading hypotheses of how human intelligence functions in that domain, as well as throwing off technologies that form the basis for the next generation of artificial intelligence. We don't execute on this loop once, we execute on it repeatedly, and this creates a virtuous loop that has allowed us to start to build the science of intelligence. And we've had significant success here. Importantly, each of these areas is throwing off artifacts, impacts, startups, new technologies, et cetera. From the life sciences side, we have new neuro and cognitive technologies that are allowing us to start to think about intervening in a clinical setting. And from the engineering sciences side, we start to see those new generations of artificial intelligence that are really changing the way we approach some of these systems, whether that's adding world models onto large language models to create a deeper sense of understanding, or taking that technology to the next level, reducing the amount of data and compute that's required. So, what is the status of our quest? We fully recognize that we are a set of research scientists. However, understanding in this particular area requires, go ahead, come on in. Understanding in this area requires that we start to think about things in a very, very different way. The computational model building is requiring that we have an integration between the science and the engineering, that we have people who are bilingual in both engineering and science. We need larger teams to approach this work. The old lab-based approach is insufficient, in our view, to try to address this, and this means that the research groups must have shared goals. Additionally, and a large focus of what you're going to hear today, we need platforms to support this work at scale. That means engineering teams who are committed to building the software systems underpinning the research that the larger teams are doing. And finally, lab cultures, and this is a long-running theme both for the Quest as well as the predecessor, the Center for Brains, Minds, and Machines. Lab cultures must evolve and continue to evolve to be able to address these changes. So this is not a simple task we've set ourselves, but one where we feel we're starting to see the first path to success. So I've talked about domains of intelligence. Our goal here is understanding human intelligence as a whole, as a single comprehensive goal, is outside of the scope, both in terms of time and funding that we have available to us. So we're going to break that up into modular systems that we can start to address. Here, we've chosen the domains of intelligence: perceptual intelligence, embodied intelligence, the development of intelligence, language and thought, and a new area that we're starting to put some time and energy and effort into thinking about, which is social intelligence. In each of these cases, the goal is to be able to produce a machine executable model of how intelligence is functioning in that domain. We call these research missions, and importantly, we don't expect these missions to support themselves in a standalone fashion. They're interacting among each other. We're starting to see integrated efforts between the missions, That will be a subject of a future talk. But these missions are supported by platforms. Here, I'll go from oldest to newest, scaling inference, a new approach to cognitive model building, BrainScore for data to model comparisons, and our newest platform, the Intelligence Observatory for behavioral data collection at scale. And you'll hear from representatives of each of these platforms as we go through the rest of the day. So, what you're going to hear today, immediately following my comments, Josh Tenenbaum and his team will present on the work coming out of the Scaling Inference platform and the Developing Intelligence mission. You'll see new cognitive modeling techniques that they're continuing to discover and evolve. Leslie Cabling, after lunch, will present on model-based and model-free approaches to embodied intelligence. Essentially, how do you take AI and put it into a robotic framework to give it the ability to function autonomously? Following Leslie, Michael Lee will present on NodeKit and running behavioral experiments. This is one facet of the Intelligence Observatory platform. And then finally, Kartik Predipan will close out the day by talking about model submission and scoring using the BrainScore platform. So I'm going to finish here, but we're very excited for the day, very excited to have you join us. And with that, I'll hand it over to Josh Tenenbaum.